Hey friends, it's me. I just dropped my daughter off at a swim meet in Valpo, but we can't go inside, so I'm sitting in my car watching it live stream and thought I could record a sample problem for you while it's in between meets here. So if you hear noises in the background, I'm in a Starbucks parking lot, hopefully connected to Wi-Fi now, and hopefully the video is going okay. And that's kind of what you're probably listening to, and that's why it's all dark and kind of creepy looking with the sleety, rainy snow and the parking lot. Anyway, moving on. So here we go. We have these three charges that are bolted to the wall as shown above. We have this Q1, Q2, and Q3. And we want to know what the net force on the first charge is going to be. So we're looking at this charge here. What's the force going to be on that guy? So whenever I look at this, I want to look at them one at a time. I'm going to ignore the third charge to begin with. So I'm going to pretend it's not there. And I'm going to look at just the first two charges. Now, remember, according to Coulomb's law, we can say that the force that the second charge puts on the first is going to be KQQ over R squared. Remember that K value is a constant. It's always 9 times 10 to the ninth. Remember that the Q is Q1 here, which will be 25.41, and micro stands for times 10 to the negative 6, so 25.41 times 10 to the negative 6. And then I'm going to put in charge 2, which is 14, which is 14.88 times 10 to the negative 6, all over the distance, which is D1, so it's going to be 5.6. And then the most common mistake is don't forget to square that value, that you always have to square that radius. So whenever we put that in, so I went to, let me see if I can find my cursor here. I went to the calculator, I plugged in those values. So that's the second one. Here's the first one, and I got 0.1085 1, 0.1085 0.10, so let me get back here. So 0.10851, okay? Now, the next question is, if I look at these two charges, it says that charge 1 is a negative charge, charge 2 is a positive charge. What I need to know then is what direction is that force in? Is it in the plus direction or in the minus direction? And if I have a plus charge and a minus charge, what's going to happen to those two? They're going to attract because opposites attract. So I don't care what's going to happen to charge 2. I only care what's going to happen to charge 1. So I know that the force that 2 puts on 1 is going to pull 1 towards the 2. And now when I look at that, is that in the plus direction or the minus direction? And the answer to that is it's in the minus direction. It's going to make this 0.10851 negative. Now we'll do the second one again, only this time we'll do it between charge 1 and 3. So I can look at that and say, hey, there's a force that 3 puts on 1. I'm going to follow the same equation, KQQ over R squared. This is going to be 9 times 10 to the ninth. And then I'm going to have the same charge 1, 2541 times 10 to the negative 6. But now I'm going to put charge 3 in there, which is 7081 times 10 to the negative 6, all over that new distance between the two of them, D2, which is 513. So I'm going to put 5.13 in there, and then I'm going to square it and see what that comes out to be. So if I come down here and I go to the online calculator, I punched that in and I got 0.61532, 0.61532, 0.61532. So 0.61532. Now again, I have to look and see, well, what direction is this going in? Is it going in the plus direction or going in the minus direction? So if Q1 is negative, and Q3 is negative. I have two negatives now. Well, what are two of the same charges going to do? They're going to repel away from each other, which means that Q3 is going to push Q1 to the other way. So this would be the force that 3 puts on 1. And is that positive or negative? That direction is in the negative direction. So I'm going to say that this is negative here. So I just found my answers then. So if I'm looking at my A, B, and C, I kind of worked ahead here. So what is the force that charge 2 puts on charge 1? That's going to be this answer. This would be negative 0.10851. 10,851. 10851. And if I look at part B, then it says, what is the force that charge 3 puts on charge 1? That's going to be your negative 0.61532. Now, how do we find a net charge? What does the word net mean? Remember that net, when we talk about forces, is the sum of all of the forces. So in essence, all we're doing to get the net charge is we're going to add the two of these together. Because they're both negative, I can literally add them and say they're going to be negative. So this would be 0.7. I probably should start on the other side. 3, 8, 2, carry the 1, which would be 2. And so there's going to be my answer for that. It'll be negative 0.72283. Now, that would be correct if it didn't ask me for a degree. But because it asks me for a degree, then I have to take this direction and convert it into an angle and say, hey, when I add the two of these together, there's a net force that's this way. What is that direction, or what is the negative x direction? It is at a direction of 180 degrees. And then I would not put my negative there because I want one or the other. If I put a negative there, I'm kind of like double negativing it. So I would have a negative 180 degrees going the other way, which is not correct. Okay, so conceptually, that's sort of the idea. Now, think through this. This is the problem that you have as number 4 in Buzz. This is a kind of a one-dimensional problem or two-dimensional problem because we're really looking at the fact that it's going only in this one direction and only in the x-axis. We could theoretically do the same thing if we wanted to in the x and the y-axis. So let's say we take Q2, which is negative or positive, we put it up here. So this is 2. We're not going to solve the whole thing, but I want to just kind of walk through it with you. Q1 down here, and we'll leave Q3 over here. So think through conceptually what's going to happen with this. I would have Q1 and Q2 are going to attract to each other. So Q2 is going to pull this up. This will be the force that 2 puts on 1, right? And won't that be equal to KQQ over R squared? And you would do the same thing that we did up here at the top, plug in all those numbers and find that value. Now think through, now thinking ahead, I should have put this over on this side, QQ over R squared. Think through these two now, 1 and 3. If I have two negatives, what will negatives do? They will repel away from each other. So 3 will still push 1 this way. This will be the force that 3 puts on 1. And it'll be KQQ over R squared. And we can plug in the same numbers, find the values for that. Now, interestingly enough, now we're really dealing with, can we literally just add the two of these if they're going in directions that are perpendicular to each other? And the answer to that is no. Remember, this goes way back to the beginning of the year when we talked about vectors. So now we would look at that and say, hey, doesn't that remind you of the vector triangle? So we would have the values here. These are our two components, and we would have a resultant that goes up the middle. So to find this resultant, the net force, then isn't it going to be the Pythagorean theorem of the force of 2 on 1 squared plus the force of 3 on 1 squared? And then couldn't we take and find our angle based off of that and say, hey, we want to come up from the 0 line here. So this is going to be there. We're going to find our theta value. Theta will be the inverse tangent of the opposite, which would be the 531 over the adjacent, which is the 521. And then because we're in the second quadrant, we would add 90 to that. I just lost my light there in my van. So what I wanted to show you this for is this is really what the extra credit problems are, where we're looking at this in the multiple dimensions, and you have to do the vector parts, the vector adding and subtracting to go with that. So you can do it, and all of you can do it because we did this in the fall with vectors. It's just a lot more work because you're doing that. So key idea, you're starting with this KQQ over R squared. You are taking and finding whether they attract or repel, and then putting the negative or positive in front of it. So while I'm saying that, one thing you may have noticed was that if this was a negative charge and this was a negative charge, notice that I did not put my negatives in here. Don't ever do that. It's way better for you to look at them attracting or repelling and then assign the negative to it. And then you have to add them by vectors. If they're all in the same direction, you can literally just add them up like we did over here on the right. And if they're not in the same direction, then we have to do all the vector math in order to get it